All right, I'm going to quickly show you how to do an exponential function. I have talked about exponential functions before. Um, I talked to you about them as, hey, I use these actually to fit where my thyroid hormone should be based on the medication they gave me because it's a dose response, there's a dose response effect. So I give a prediction by, and it stabilizes every 4 to 6 weeks. And so I come into the doctor's office and I say, this is where my models predict where I should be. And then he checks my labs. And so far, they've been pretty dead on. So they're, again, something like the Bayesian model, super useful. And it's not lines. So it's great that we're doing the second because I do think they're in importance, they're probably second exponentials. There are just so many things that we encounter in daily life happen to do this. I would read this. The readings are really short, they're informative. I really would recommend that you read this. And there's these little chart here that if A is bigger than 0, the like how the graph should look like. And but I'm going to quickly show you how to fit one of these. All right, so how do you do that? If you look at the first plot here, the purple graph, um, I'm using the basic structure, which is this. And the first thing, I'm just to be lazy, I'm still going to pick points. So my slot method, if I go here with my cursor and just go up to the graph, it looks like the first point is at x equals 0, y is equal to around 11. The second thing I notice is that this thing looks like it's leveling off at 0. The D that's there tells you where it levels off at. Since it looks like it's leveling off at 0, I'm going to assume that D equals 0. If D is not 0, this becomes really painful to solve. I need one more data point. I'm going to choose something hopefully easy. Let's just pick a right on here, x equals 4, y equals 3. That's my second point. All right, so from the first point, so step 1, I get when x is 0, y is 11. Plug it in, I get 11 is a times b to the 0 plus 0 because d is 0. So I get from here, b to the 0 is going to be 1. Anything to the 0 power is 1, except 0 to the 0, so be careful. But assuming b is not 0, I get this guy is 1. And so I get a equals 11. And so now what I have is I have y is equal to 11b to the x. That's my model so far. Next step is to get rid of b. If I get rid of b, how I do that is I pick the second point that I have. So let's change the color here. And step 2, use point 2. And if I do that, I'm going to get y is 3 and b is unknown, but my x is 4. So I plug in x is 4, y is 3, and I have this thing. How do I solve that? Well, first I isolate the exponential. So the b to the 4th gets isolated, and I bring the 11 over to the other side. And then I take the 4th root of both sides. I like laws of exponents. So I take both sides to the 1/4 power. This gives me b here. And over here, I just go on a calculator and put in 3 divided by 11 in parentheses raised to the 0.25 if I want to be as fast as possible. And I get, this is approximately 0.272 3. So that gives me my b. So my final model, I'm going to put it in red over here. My final model looks like this. Y is equal to 0.723 and 11. Sorry, here. Let me erase. I forgot my 11. That's where the a goes. B was 0.723 to the x. And this is how I use it in the doctor's office. Once I figured out the a and the b, I just plug in my time. X would be my time. And so if it's been 3 weeks since I started my medication, I'll say put in 3 weeks and it'll predict for me where my thyroid should be. It was supposed to, if it's supposed to increase, it'll be the other way around. So in your notes, they have a picture of what it looks like when it's increased as a function. So your exponential functions, depending on a and b, could look different. Something that's decaying, the b is a fraction, and it looks like this. Something that where b is bigger than 0, or bigger than 1, it looks like this. So this is b less than 1. This is b bigger than 1. And these are with a is bigger than 0. If a is less than 0, it's going to be reversed. It's going to be reflecting it over the, so if you've made a picture of this, it would go the other way down. Be something like this. Let's see if I can draw this perfectly. So every single one of your positive numbers would be negative numbers, so they would go like this. Like this. That would be, it'd be the whole picture if I folded right here and reflected it over and turned everything negative. So anything positive would be negative and just mapped it to it. I would get this picture here. And same thing over here. This number would be down here, and I would get something that goes down like this. All right, so I would definitely read up. In the notes, they don't have you solve for the other type of equation. The other form of this equation is y is equal to, let me change the color. Y is equal to a times 1 plus r to the x plus d. Just looks a little different. I'm pretty sure. Yeah, this just looks, it's a different form of the exponential function. But there's nothing in the notes calculating this. Not easy, but if you have 3 parameters, these 3 things you have to fit, you need 3 points, and you have to slog through it basically, unless that you know the d is 0. So same kind of tricks though. Hope this helps.